video on lessons 1 through 4, the review. So on this first one, it's kind of easy. It says find a rational expression equal to the one that has a denominator of x minus 3. So basically they just want it reversed. And if that's all they want, then you just stick the negative sign out in front. So that's the same as if you were to say negative 4x minus 5 over x minus 3. But basically what you're doing is you're just multiplying both the numerator and denominator by negative 1 to reverse it. So that's your answer. Okay, on this next one, we're just using PEMDAS. So you do your parentheses first, your exponents, then your multiplication, division, and addition, subtraction. So if you work this out in steps, this would be 12 minus 6 and 28 divided by 7 and 54 minus 45 and 55 minus 30, and then just bring down the other numbers. So this would be 6 minus 4 plus, this looks like that'd be 9 plus 25 plus 2. And so let's just add those together. 6 minus 4 plus 9 plus 25 plus 2, that gives you 38, which is what the answer is. Now, if you were doing this all in one step in the calculator, make sure you use parentheses, not brackets or braces on the calculator. And make sure your opens and closes match up where they should. Okay, on the next one, it's about inequalities. And you have a negative x here, and so all you do is you think I'm multiplying or dividing by negative 1. And so that just reverses everything. So then you say negative 2 less than x less than 6, and they wanted an interval notation, so you use parentheses. So that's pretty simple. Also, you pick the right graph. So you don't want the ones with the 6 endpoint. You want ones with the negative 2 endpoint. And this one is closed because it includes negative 2. This one is open, which means does not include the negative 2. Okay. Okay, so those were the easy ones. Now on this one, it says write using radical notation. Now for the numerator one, you've got a negative exponent, so that whole thing comes down. So this, let me just make a note, this entire numerator goes to the denominator. But in the denominator, you have 6x to the negative 1/7. The 6 is not going to move.
Hey, can I get to the bathroom?
The x to the negative 1/7 goes to the numerator. The 6 stays. And so how that looks is you're going to have x to the 1/7, and then you're going to have 6, and then you're going to have 36x squared to the 1/2. Okay, so you basically move the x to the negative 1/7 to the numerator. Remember, the negative sign means it's a ticket to move, And in this case, you move it to the numerator and make it positive. And on this part, it's a ticket to move it to the denominator, and looks like that. So what we do with that is keep the numerator the same, and this 1/2 power means the square root of 36x squared, and so you got to simplify that. So that'd be x to the 1/7 and then 6. So the square root of 36 is 6, and the square root of x squared is x. So it's going to look like that, x to the 1/7 over 36x. Now the next step is we've got to bring this down. So even though both are positive, you move this one down because you're going to think that x to the first is the same as x to the 7/7. And you do 7/7 minus 1/7 to get 6/7. And so you'd have a 1 in the numerator, and you'd have 36x to the 6/7. Now, what I've seen is that answer is not counted right on Math Excel. It needs to be in the other format with 1 over 36. Now think of your denominator needs to be the root. So I'm going to make a note. The denominator is the root. So in this case, that's 7. And then underneath here is your x to the 6th. And so that's why that's right, like that. Okay, now on this one, it looks a little complicated with your fraction exponents, but the whole point is you have to do FOIL. So 7x to the 1/7 times 7x. So that's going to give you 7 times 7 is 49, and then you have x to the 1/7 times x. Now remember, if you have like bases, you add your exponents, so it's really 1/7 plus 1, or you could think of 1/7 plus 7/7 to give you x to the 8/7. And that's what they have for the F. Now for the O part, you're doing the outsides, which are this times this. So we have 7x to the 1/7 times negative y negative 1/7. And so you're going to have a negative, and it's a 7x to the 1/7 y to the negative 1/7. Now on the directions for this one, it says use positive exponents only. And so that means if it's negative, you have to move it. So in this case, we're going to keep the 1/7 for the x on top, but since the y part has negative 1/7, we have to move that down. So that's the O. And then you do the same thing for the I. The I is going to be the insides, y to the negative 1/7 times 7x. And so that's going to just be 7x over y to the 1/7, which is that. And then your L is y to the negative 1/7 times negative y to the negative 1/7. And so on that one, we keep negative 1 in the numerator, and then y, and then negative 1/7 minus 1/7 is negative 2/7. But since we're moving it, it's just 2/7. And so that's what they have there. So that's how that one works. All right, on our next one, we take steps on this. You're just doing 45 divided by 20 on the calculator, or you could just simplify it like divide by 5 to each, and that's going to give you 9/4. So the number part is easy, Now for the other part, you have m to the negative 19 and m to the 19. On this one again, we want positive exponents, so this has to come down. So this will be 1 over m to the 19 plus 19, which is 38. And then for the n part, we have n to the 13 over n to the negative 15. This time, instead of moving it down, you have to move this one up. So you have n to the 13 plus 15, which is 28. And now that you have all those, you just put it together. The 9 goes in the numerator, the 4 goes in the denominator. The m to the 38 goes in the denominator, and the n to the 28 goes in the numerator. So that's that one. Okay, now you have a couple that are related to college algebra. So on these related to college algebra, you're going to need to do the slope. And so you solve for y. So if you have x plus 4y equal 9, then 4y is negative x plus 9, and y is negative. You can think x over 4, or you could think negative 1/4 x, which is probably the way I prefer it, and then plus 9 over 4. Now technically that's the same as negative x plus 9, all of that divided by 4. But when we're trying to do slope-intercept form, that means y equal mx plus b. And so that's why we really want the negative 1/4 in front, because that's your m, which means down 1, right 4, and then this 9/4 is your y-intercept. So that's what you want. And just notice that on this one, you need to type your y equal, but on the very next problem, don't type y equal. Now, notice I'm not completely done with the problem. All I'm doing is getting my slope, because if we want parallel, parallel means it's the same slope. So if this one was negative 1/4, then the other one is also. So basically m1 equal m2, which is negative 1/4. Now for the next part, you're going to have to do y equal mx plus b, but you have to use the point given. In my case, it's 3, 6. So that means we'll call x3 and y6. So 6 equal negative 1/4 times 3 plus b. So we get 6 equal negative 3/4 plus b. Add, so 6 plus 3/4 is like 24/4. So that gives you 27/4. Now, that means you're going to go back and say y equal, your slope was negative 1/4, and then your b is the 27/4, like that. Now, if you don't like getting your common denominator, you can just say 6 plus 3/4, and there's your 27/4. So that part you can do in your head or on your calculator. Okay, so for this next one, you're doing something similar, except for this time it's perpendicular, so that means the opposite reciprocal. So we're starting with 6x plus 5y equal 3. So 5y is negative 6x plus 3. Then divide each term by 5. So we get negative 6/5 x plus 3/5. So slope 1 is negative 6/5. The easiest way to remember it is because it is the opposite reciprocal, that just means flip it and change the sign, so that's 5, 6. Now that's because you basically have m1 times m2 equal -1. And so if this is -6/5, and that's m2, and this is -1, you basically cancel your negatives and flip it. So you need a 5, 6 there to make it -1. So that's the reason why that works. So we have to use 5, 6, which is what they used for the answer. Now we have to go through that other point though. So let's use y equal mx plus b with the point 5, -3. So this is x, this is y. -3 equal 5, 6 times 5 plus b, and then just work that out. You are going to get fraction answers, so don't be surprised about that. We're going to do -3 minus 25, 6 equal b, and I'm just going to type that on the calculator. -3 minus 25, 6 is -43, 6. And so that's what they have for the y-intercept. So your answer is 5, 6x minus 43, 6. But in this case, they already have the y equal typed for you. Now, if you wanted, if desired, use y minus y1 equal m times x minus x1 instead of y equal mx plus b. You'll get the same answer. I've seen teachers say before, if you have a point and the slope, use the point slope, which is what this one is. But my experience with students is they prefer using the slope intercept. So anyway, that's how that works. Now on this one, we want to solve by graphing. That means basically you got to solve for y and turn it into f1. So on this first one, I'm going to move the -3x over. So it's positive 3x plus 24. So you get -3/2 x minus 12. Because 24 divided by -2 is -12. Now on this other one, I have 3x minus y equal -6. If it's something without a coefficient in front of y, I'm going to work it a little different because it's easy. I'm just going to add y to both sides, and then I'm going to add 6. So I have 3x plus 6 equal y. And so then we just want to graph it. So the first one would be f1, the second one would be f2, and we want the intersection. So we go new document, add graph, -3/2 x minus 12, and then we have 3x plus 6. So they cross right there. Menu, analyze, intersection. The intersection gives us our answer, and so that's -4, -6. So that's your intersection. Now, when you're graphing it, use whole numbers because you don't know exactly how far. So use the table when graphing points, or use slope, which is rise over run. So in this case, what I would do is I would plot where negative 12 is. So that's right here. And then I go, okay, so start with negative 12 and then go down 3, right 2. Down 3, right 2. Well, that gives me this spot, which is at the middle. And then I go down 3 again and then right 2. So those are the 2 points I use. So I use 4, comma, negative 18 and 0, negative 12. So again, if you just want to go to your table and get that, for the first one, there's the 0, negative 12, and there's the 4, comma, negative 18. Okay, and then you would do the same thing for this one. Start at 0, comma, 6, and you want to go up 3, so start at 6, and then go up 3, right 1. So 3, 1, and then 3, 1. So that's this one. So that gets you to 2, comma, 12. Now remember when we're looking for that on the second equation, the first one was blue, but then we go over to the right and now it's red. And there's the 0, 6 and the 2, 12. So that's how you do that. Now on this next one, it's a system of equations, and there are many ways to do the systems of equations, but the easiest way is with matrices. Now, a common mistake on this one is this has A and B, this one has A and C, and this one has B and C. So you can't just type the numbers. In your matrix, you're going to need an A, a B, a C, and then the number. So it's bigger than you think. So then you go 4, 7, 0, 15. 8, 0, 4, 16, and 0, 6, 4, 6. So that's how you set up your matrix, and then you're basically going to do REF and then put parentheses around it. So this would be considered a 3 by 4 matrix. Okay, so on your calculator, we type RREF, or you could do menu 7. So type RREF parentheses, or do menu 7, because 7 is matrix and vector, and then 1 for create, and 5 is the reduced row echelon form. So 5 is what we need for RREF, and 1 for create. That's reduced row echelon form. We just call it RREF. Okay, so do 5, and then do menu 7, 1. Do 1 for matrix. This is a 3 by 4, so 3 tab 4, press enter, and then just type your numbers. 4, 0, no, 4, 7, 0, 15, 8, 0, 4, 16, 0, 6, 4, 6. Okay, so when we do that, we get this diagonal ones, which means we did it right. So it goes 1, 0, 0, 0, 1, 0, 0, 0, 1. And then these numbers over on the right are your answers, 2, 1, and 0. So this is your X, this is your Y, and that's your Z. So there's your X, Y, Z, 2, 1, 0. Okay, now we just have a couple on factoring. So on this particular question, they're all even numbers. So divide by 2 or 4, whichever is the GCF. In this case, it's got to be 2. So we have 2 times 4r squared minus 15r plus 9. Now, the next part of this is keep the 2, and you can do trial and error. You can try 4r and r, or you can try 2r and 2r. It just depends on what numbers you have. In this case, we want 4r and r, and since we need 18, we need 2 times 9. So the 9 goes here. So on this one, we have a positive 9. And so that means you're either going to use plus 3 for both of them or minus 3 for both of them. And since we need negative 15 in the middle, then they both had to be negative. So that's your answer. Now, if you don't like that method, you could graph it and look for the x-intercept. So this would be a backup method. We'd say function 1 is 8x squared minus 30x plus 18. Then you don't even have to work it. 8x squared minus 30x plus 18. Enter. So there you can see where your answers are, and you want the 0 of the graph. So that's the first option. So the first 0 is 0.75, which is really 3/4. And the other one is, let's see, let's move this, 3/0. Now, whenever you're doing things like this, you'd think of this as x minus 3/4, but you really got to change it to 4x minus 3. Because if you have a denominator, then that's really going to be your coefficient. And then for your last step, notice we had 8r squared, so we need to multiply by 2. And so that gives us a 2 there. And then also change all the x's to r's. So 4r minus 3, and then r minus 3. So that's what matches this answer. Okay, and so then for this last one, what you can think of on this, let's type 12x squared minus 13x minus 35, and then use your calculator for the x-intercepts, which are the zeros. And so let's do that. Notice you're given 2 variables, but I'm showing you an easy way to get it, because you can't do x and y on the same side if you're going to have f1. So if you follow this, you're going to do 12, whoops, I needed to do my graph. 12x squared minus 13x minus 35, enter, and then 0 of the graph. One of them is, let's see, negative 1.25. And the other one is 0.3 repeat. Now, notice there is a 1 at the very end of here, but it's so many 3's, so we don't care. But I do need to move it up because there might be a number in front of that. Yeah, it should be. This is 2.3 repeat. Okay, so that's 2.3 repeat. Now, how we convert those to fractions is like go to the calculate part, do negative 1.25, menu, number, fraction. That gives us negative 5/4. And and then type a bunch of 3's. Remember, the key is to go at least halfway. Then do menu, number, fraction, and that gives you 7/3. So like we said earlier, if you have a denominator, then that goes in front. So like 4x minus 5. And then, let's see, 3x minus 7. Except for, I need to change this one to be plus. Because if I'm going left, then that means this has got to be plus. And now that was left 5/4, so the factoring needs a negative. Needs positive. So that's very close to our answer. Then we just use the right variables. So this is 4c plus 5r and 3c minus 7r. Or you could reverse it. I'm sure in that case it would just count it right if you had it reversed. So anyway, that's the easiest way. The other way is just trial and error. Like if you have a 12, you could do 6 and 2 or 4 and 3. And it's just a little bit harder process than this. So I hope that helps. Have a good one.